Hey, sorry if you just got on this video. I forgot to start recording the first example, but plenty of examples to catch on. All right, here we go. According to 45 degrees, what side is the x? That is the adjacent side. According to the 10 that I was given, what side? According to 45, what side is 10? Oh, man. I've gotten it. So now we have what trigonometric ratio? Cosine of theta equals adjacent over hypotenuse. So the cosine of 45 degrees is equal to x over 10. 45 degrees is a special one. So we say, what is the cosine of 45 degrees? Brooke, can you tell me what it is?
Is it opposite to 2?
It is square root of 2 over 2, or radical 2 over 2. And so we say radical 2 over 2 equals x over 10. And we cross multiply. And we get 2x equals 10 square root 2. Divide by 2. X is 5 square root 2. I wish I could make that thing bounce like that on purpose. Can't even work. Alright, now we have to find y. So according to the angle, which side is y? And I'm going to, again, use the side that's given, not the one I just found, just in case I made a mistake. So we're going to be using sine theta equals opposite over hypotenuse. So sine of 45 degrees is equal to y over 10. What is the sine of 45 degrees? Radical 2 over 2. It's the exact same as the cosine of 45 degrees. So since it's exactly the same, I think I can just put my answer now, because these are exactly the same. There are two triangles. Do it using trigonometry, so I can tell you use trigonometry. Because we are working on learning these values. We are working on learning these values. You can do it without looking at your chart. Start working it up. The first thing you got to do is figure out which sides you have, or need to find. What does theta stand for? An angle. Good. So that means I'm putting 30 degrees in the theta spot. So Tim, what is the cosine of 30 degrees? So radical 3 over 2 equals x over 12. Cross multiply. So x is 12 radical 30, so x is 6 radical 30. Sine is the opposite. We're using opposite with hypotenuse. I just said what I didn't mean to say. Y is the opposite. We're using opposite of hypotenuse. That is the sine of theta. So we do sine at 30 degrees equals y over 12. Bree, what's the sine of 30 degrees? So low. Okay.
But
Sine of 30 degrees is, everybody, sine of 30 degrees? 1.5. Cross multiply, we get 2y equals 12, so y is 6. This one? This one?
yes.
Well, did you get 12 times radical 3? Oh, that is the cosine of 30 degrees.
Oh, okay. You didn't sign twice.
Okay, and then this one, we will do the, what is this, adjacent, hypotenuse. Cosine theta is adjacent hypotenuse. So cosine 45 x over 6. Cosine 45 degrees, Ellie. Radical 2 over 2. So we cross multiply and we get 2x equals 6 radical 2. Divide by 2. X is 3 radical 2. We go, we do the other one. This is the opposite. We use hypotenuse again, that's sine. I need data, sine of 45 degrees. Radical 2 over 2. It's the exact same as the cosine of 45 degrees. Because they're exact same, I don't really need to do much except for write my answer. We do okay? Okay. What? Oh, instead of y. Oops. Okay. Let's see how good you are. Let's see who am I going to call on.
What are you doing?
Learn to write. Say that. Sine of 30 degrees. Good job. Carly, sine of 30 degrees. Good. Look, sine of 30 degrees. Very good.
19.2 degrees.
Take up. Sine of 30 degrees. It's not. Read. What angle has a sine of 1/2? Okay, so you guys all know what the sine of 30 degrees is, yeah? Type it in your calculator. Type sine 30, and let's make sure it really does say a half.
Why? Why is it?
No, I will explain it. Okay, calm down. Calm down. It's not time for that. So you guys know when we measure length? If I were to measure in the United States, I'd measure length in like inches and feet. But if I go anywhere else in the world, I measure in like meters and centimeters and kilometers. Okay, so there's different measurements for angles as well. So you know degrees, but there's another kind of measurement for angles which we will be learning about. I think it's in the next section, called radians. And if your calculator is currently in radian mode, it's not going to tell you the right answer. It's going to tell you yours is in radian mode. Okay. Well, anyway, so if I can show you what it looks like. If you had it in the wrong mode, you would have gotten something like that. Okay? Because that's so to fix it, you're going to go to the mode button, which is right there under quit mode button, and then there is a radian/degree mode. So you need to make sure that it is in degree mode by hitting enter on degree. If anything that has to do with angles, you would have to know which mode to have it in. And like I said, today we're doing degrees, but I think next section I have to look. But I think next section we're doing radians. So you are going to learn what radians are, and then we will use mostly radians in here. And then next year you'll use mostly radians as well. So you'll have to know both of them. And you'll know what it means hopefully after I teach it. But just for now, you've got to make sure you're in the right mode. So doing sine 30 is a good way to check, or just go on your mode and look. Okay. So now, before we do any other examples, how would you find the cosine of, I don't know, 15 degrees? You would type it in. You'd hit cosine 15 degrees. And when you do this, the book is going to ask you to round to 4 decimals. Okay? So we're going to get 0.9659. 0.9659. How about the tangent of 89 degrees? These? No. No. Anything you're about to memorize are 30, 60, and 90. Everything else, you would use your calculator for. Okay? Which is why you have to have a calculator for this class. There is a chart. You can memorize the chart if you want. Okay, now we have to round to 4 decimals, and I gave you this one because this is going to be a fun one to round. But I'm just going to write, oops, not. Sorry, I wasn't looking at it. Yeah, it's 57.2899616. Okay, we're rounding to the 4th decimal place. To round to the 4th decimal place, you look at the 5th. So when we round, we look at the next decimal place. What's the 6 tell me to do to the 9? Round it to what? Round it not to 0, but you're rounding it to what number? 10. So when I make this a 10, I have to carry that 1. So now, that's going to become 10. So I got to carry that 1. And yes, so rounding it correctly, it's going to be 57.2900. If you round wrong, you will lose points. Question. Okay, well, let's do another one. Maybe you can think of your question. All right, so the next one I want you to do is the cosecant of 10 degrees. Oh, where is that button? You don't have one. No. Actually, here, let me make it easier. Start. Let's make it an easier one. Let's make it one that you already know the answer to, so you can figure out how to do it on the calculator if you're trying. The cosecant of 30 degrees. Do you know the answer? It's in your chart. 30 degrees. The answer should be 2. And there isn't a cosecant button. type in cosine or cosecant, or you try to type in the -1, it gives you an error. Because that's not how you do that. So the cosecant is the reciprocal of sine, and on the front page where we had all those formulas, we also had that cosecant theta equals 1 over sine theta. So to type it in their calculator, you type it in as 1 over sine 30. So type in 1 over sine 30, see that that equals 2. I've never used this. All right, try another one. How about the cotangent of 2 degrees? It's helpful to put on your notes, since I didn't do anything notes, it's helpful to put on your notes what you typed into the calculator, so you remember later. So you should get, if you typed in your calculator correctly, 28.6363. Did you type it in right? What did you type in? One over tangent. So we needed to know how to type those in, because now we are going to be solving right triangles, but they are not special right triangles. They're just any other right triangle, not the special ones. So here, before we go on, to solve a right triangle means to find all missing sides and angles. All missing sides and angles. That's what solving a right triangle means. Let me fix this. It's kind of messy right there. She's gonna bring me in a bag of candy soon. Yep. For all the candy that she's taken.
You noticed that?
I'm a mom. I have eyes in the back of my head. I've got eyes on the side of my head.
Okay. Let's go out to school.
All right. Let's have a triangle. Everybody brings in triangles shaped.
What? Just take all the broken Doritos.
Or circles, because we're doing circles too. Or anything high related. We're doing like a pie related.
What am I gonna do? I can't grab them up there.
I'm so shook. You're not gonna do it. All right, guys. What do we have to find? We have to find which angle? Which angle is missing? We know angle A, we know angle C, so measure of angle B we need to find. Remember in geometry, when you find the measure of angle B, you write little m, angle, capital B. The capital stands for the angle, little case is sides. So the measure of angle B, to find that, what do you do? I do not use the 90 at all, because there was a, I mean you can, it's just more work. There was a theorem in geometry that said if you have a right triangle, the other two have to add up to be 90. So I just do 90 minus 28. It's just a little bit faster. And we get 62 degrees. Okay, got my first answer. My next answer is, which side do you want to find next? A or C? Come on. Okay, let's find C. C is the hypotenuse. And according to the given angle, which is 28, what other side do I have? Okay, the adjacent. So what uses adjacent and hypotenuse? Cosine of theta equals adjacent over hypotenuse. That's from SOHCAHTOA. So now I plug in the information. Cosine of 28 degrees equals 15 over C. So you do not know the cosine of 28 degrees because it's not one of those from our chart. And it is going to be a horrible decimal, so I'm not using my calculator yet, but I will end up using it. I'm just going to leave it as cosine 28 for right now, and I'm going to solve for C. So to solve for C, we are going to make this into a fraction, and then cross multiply. So I will get C multiplied by cosine 28 equals 15. So cross multiplying. And then I have to get C by itself. So what do I do to both sides to get C by itself? Divide by cosine 28 degrees. So now I have C equals 15 divided by cosine 28 degrees. Is there a question? At this point, you now use your calculator and do 15 divided by cosine 28.
That's not the answer.
No. Okay, so Brianna, tell me the answer approximately. Oh, we're gonna round these to 2 decimal places. Sorry, we're gonna round these to
Approximately
16.99 is correct. Rounded correctly. So now we have our C value. We still need to find A. So according to the angle, I'm going to go back to the angle again, 28 degrees. Side A is the opposite. And we are going to use the given side adjacent. So what uses opposite and adjacent? TOA, tangent. So we'll do tangent of theta equals opposite over adjacent. So we plug stuff in. Tangent of 28 degrees equals A over 15. We will put the tangent of 28 over 1, and we'll cross multiply to get A by itself. A equals 15 multiplied by tangent 28. And it's by itself. Once it's by itself, type it in your calculator. Everybody practice typing in your calculator. Make sure that you have the same answer. You're typing it in correctly. Ellie, can you give me the answer? 7.9. Good. All right, when you're ready to launch, please. So trigonometry in real life is not used to solve a right triangle. It's used to find measurements that you can't actually go measure. So you guys have a picture, mine doesn't have a picture, but you have a canyon, and while you're standing at point A, you're measuring the angle of 90 degrees between B and C as shown, labeled in your graph, or in your picture. Then you're going to walk to B and measure an angle of 76 degrees between A and C. And the distance between A and B is about 2 miles. So how wide is the canyon between A and C? So you can't really take a tape measure across the canyon and measure it. So you have to use trigonometry to figure out how wide things are. They can measure how tall things are. This is not big. Thank you.
Thank you.
Now you guys can run quick. Good.
Perfect. Because I never would have.
Oh.
I wasn't smart enough to get into the trig class, okay? Easy.
And now they have to take it.
Now you have to take it for a reason, so you're not a social studies teacher. You can't do that.
Wow,
She
She didn't. They didn't have to take trig back a long time ago when she was. Just kidding. She's like way older than I am. All right, you guys. So we are finding side x, and according to the angle, which side is side x? Opposite. According to the angle, which side is given? 2 miles. What side is that? The adjacent. So what uses opposite and adjacent? So TOA. Which one? Tangent. TOA. So tangent of theta equals opposite over adjacent. So tangent of 76 degrees is equal to x over 2. How do we solve it? But I have to cross multiply with something. What do I need to do? Is it over 1, then cross multiply. So I get that x equals 2 tangent 76 degrees. Type it in. All right, Reed, tell me what you got. 8.02. And then since this is a real life question, we're going to have some units when we're done. 8.02 what? Miles. So there's no way we're measuring across an 8.02 mile canyon with a measuring tape. So trigonometry is used a lot in real life for things that we can't actually do, like by hand. And there's another question. In example 5, find the distance between B and C. So I'm going to stop talking for a moment. Let's see if you can find the distance between B and C now. Same picture. What you can do is start thinking about how you can set up the picture. That's probably the wind.
So you to be quiet.
So you don't need to find the other angle. You don't need to. I mean, you can, but just use the same angle. So I know you can do it that way, but if you're going to do it that way, you need to use the entire answer, like not the easier to do in your name. But let's start with the trigonometry. So if we're finding the distance between B and C, I'll just call that Y. Oops, I could draw a Y. There we go. According to the angle 76, Y is the adjacent. And no, it's not. Y is the hypotenuse. And we know the adjacent. So we'll be using cosine. So the adjacent is 2, and Y is the hypotenuse. So we put that over 1. We cross multiply. You get 2 equals Y multiplied by cosine, 76. But that is not solved for Y. We have to divide both sides by cosine 76. Type it in your calculator. Good. Units. So when we do real life stuff, make sure we put our units down. Duncan, did you get an answer?
8.27 miles.
8.27 miles. Perfect. Well, thank you for saying units. All right, we have 2 more questions, and then we're done. Now, this next thing is something that even my pre-calc kids continue to mess up because they refuse to hit us kinesthetic learners sometimes. Kinesthetic means we're going to do it. We're going to do it with our body. Do it with me. I need everybody in this room to give me a horizontal line with both arms. Horizontal line. What's horizontal mean? You know what horizontal means? Horizontal. Okay. Now, what we're going to do is we're going to make an angle of elevation. What does elevation mean? It means to go up, right? So only one arm go up. The other arm stays horizontal. So if you start horizontal, okay, this right now, are either of my arms horizontal? Aiden, are either of my arms horizontal? Okay, you have to have one of them horizontal. And then you go up and you look at the duck. That is an angle of elevation. So, well, I put mine down. So an angle of elevation has to start horizontal. And then it goes up. Angle of elevation starts horizontal, goes up. Angle of depression starts horizontal. One of your arms goes down. Angle of depression starts horizontal. One arm goes down. You see, I still have a horizontal arm. Okay? One of them has to be horizontal at all times to have this correct vocabulary. So angle of depression, horizontal, and then angles down. What? So we have a parasailer. Do you know what a parasailer is? They're like have a big sail, but they're attached to a boat, like being driven by a boat. So the wind allows them to fly rather than jumping out of a plane. Same concept, but you're attached like with a rope. People die. People die. A parasailer is attached to a boat, but they grow up to 72 feet long. The angle of elevation from the boat to the parasailer is 28 degrees. We have to estimate the parasailer's height above the boat. So what is going to be hard is you have to figure out what the picture looks like. This is the hardest part of this whole section. Is you have to read it and figure out what the picture looks like. So I like to draw an actual picture so it like makes sense. I'm not going to just draw a triangle. I'm going to draw a picture. So I'm going to have my parasailer. Okay. You do not have to take as much time, but you know. You gotta hold on to something though. Okay. Now where's my boat gonna go? Okay, so if you think about what's actually happening, the boat is pulling the parasailer. The boat's got to be down here on the water, because boats float on water. And then attached by a rope to his face. No. So now the angle of elevation starts at the boat. It says it starts at the boat. The angle of elevation starts where? Horizontal at the boat. Horizontal, then it goes up. So you need a horizontal line at the boat that goes up. That's where I put 28 degrees. So now I have a right triangle. I have to have a right triangle to do any of these. I do have a right triangle right here. The question is, estimate the parasailer's height above the boat. But the parasailer is not above the boat. So what's that mean? So if the parasailer were right above the boat, which you couldn't do because it's not like a balloon, it would be that distance. So I could just move that same distance over here. Those distances would be same. I probably didn't draw it perfect because I'm not standing right in front. But like, this forms a rectangle as well. So those two distances would be exactly the same. So I don't want you to read this and literally put the parasailer above the boat because that's not how it works. You have to like understand how life works to draw these pictures. Okay. All right, now we can solve it. So according to the angle, oops, I forgot something. I'm sorry. Yeah, that's the rope. Where's the rope? Yeah, the red line, the hypotenuse. Okay. All right, now we can do it. According to the angle of 72 feet, you already said is the hypotenuse. And we have to find the height. So what uses, what's the H? What is that side? Opposite. What uses opposite and hypotenuse? So sine of theta is opposite. No sitting in math. No. Sine of 28 degrees is equal to H over 72. I bet it's going to be close to a half. I mean, close to half of 72. Because it's 70. I mean, because it's 28 degrees. Never mind. You don't get that yet. You don't get it yet. Okay. So we're going to cross multiply, and we will get H is equal to 72 sine 28 degrees. Type that in your calculator. And Shay's going to tell me the answer. Next, number 4. 33.80. And then that is in what unit? Feet. All right, last one. We got to draw a picture. A ship is seen from a lighthouse at Port Richey at an angle of depression of 15 degrees. How far from Port Richey is the ship if the lighthouse is 52 meters high? What should I draw for? The lighthouse. Okay, let's draw the lighthouse. I'm not done yet. Oh, damn.
No noise. Your gunshot.
Draw your lighthouse.
Oh, I'm with the dogs.
Only once today. And then once yesterday. Yeah. That's what they look like. Look it up.
What is the lighthouse?
Not all of them. Not all of them, but the fun ones.
Siri, do lighthouses like candy true or false?
True or false? Wait. He said, did it look like pancakes, true or false?
And what was the answer?
It said the White House, and then it started giving me a definition of the White House.
Oh, you didn't say it clear enough. Okay, so now I've got this port, and I've got a ship somewhere out of a sea. There you go. And let's see, the lighthouse is 52 meters high. What are you confused about? What's confusing?
There you go. Nope. Nope.
All right, you guys just wait till I judge your drawings tomorrow. Okay? That's not nice you are to me. We're going to reciprocate that nice to that. Okay, so we have to have a right triangle. We have to have a right triangle. So So I can kind of see there's going to be a right triangle here. But I have a problem because this says an angle of depression from the lighthouse. Okay, so there's somebody standing up here looking at the ship. Okay, angle of depression, remember, starts where? Horizontal. We need a horizontal, and then we need to go down. That part's not drawn, but I can draw it in. Yeah, it's like a rectangle. Yeah. Mm-hmm. So the angle of depression is actually from horizontal down. It's going to be outside of that triangle, and that is 15 degrees. But you've taken geometry, and you can actually find both inside angles by knowing that's 15 degrees. There's this thing in geometry, and it is called when we have two parallel lines and a transversal. This angle and this angle down here are congruent because they are alternate interior angles. That's 15 degrees. Or, if you don't remember that one, even though you should, it's totally important, these two angles right here make 90. So that angle is
Big mental math.
75 degrees.
Big mental math.
So you could use either angle. What are we trying to find? I didn't even.
Angle of depression.
Angle of depression 15 degrees. How far from Port Richey is the ship if the lighthouse is 52 meters high? We have to find this amount right here. So according to, we got to figure out what angle I'm going to use. I feel like I'm using 75 because I made it purple. All right, so according to the 75 degrees, what side is X? Opposite. And what side is 52? Adjacent. What am I going to use? Tangent of theta equals opposite over adjacent. So I'm going to have tangent of 75 degrees equals X over 52. Cross multiply, we get X equals 52 tangent, 75 degrees. And then type it in your calculator. Again, that's not something we could measure with a tape measure. You need to understand trigonometry to find how far that ship is from crashing into a lighthouse. You ever driven by or rode in the car by and you saw those guys with like the tripods, like looking? Yeah. Those are called surveyors, and they're using trigonometry to measure things that they can't measure. That's an entire job. Mm-hmm. And it makes pretty darn good money. Like 80s? No, 80,000. Like 80,000 a year. Like 80,000.
Oh, 80,000?
A year.
That's pretty good.
Yeah, what are you planning to do? That makes sense. That's more than a teacher knows.
Oh, it's wrong. He said longer.
That's me working out.
Oh, that's what he's doing.
Yeah.
What are you doing?
I work at Wazer.
No, what are you going to
What are you
do?
going to do
Oh,
later?
I'll get a teacher.
Oh, yeah.
That's not more than that.
Huh.
Yeah.
All right. Jacob, what'd you get? 52, 70, 75. Yeah.
194.07 meters.
07?
This what?
Did you say 07?
Yeah.
Oh. Is that right? Yeah.
Is that wrong? What happened?
Well, I just can't remember. I can remember. And I wasn't looking at it. Yeah, I did. All right. Your assignment is in the book, and I have books you can borrow in class, but please do not borrow. We have lots of books. Please do not borrow two per partnership. So either take pictures, or I'll put it up here, or just borrow one book per couple.
I'm going to start